Hi, welcome back to Leetcode. So in this video, I am going to discuss the second problem from today's weekly contest 501, that is count valid word occurrences. So what is the problem? Problem is that so you are given an array of strings chunks. Okay, the strings are concatenated in order to form a single string S. Okay, so that means we actually have multiple strings. First of all, we will merge all of them into a single string, and that string will call as an S. Okay, next is that you are also given an array of strings queries. So a word is defined as a substring of S that consists of lowercase English letters A to Z. Okay, may include hyphens only if each hyphen is surrounded by lowercase English letters. Okay, so that means first of all, I will merge all of the strings that actually present inside these vector chunks into a single string, that is S. Now actually that they mention that I will actually create a substring of from that S, from the single string S. So that is actually strings actually what is possible as a word. Okay, so what actually may contain the valid English lowercase English letters, that actually small a to small z. Okay, and it may include hyphen only if each hyphen is surrounded by lowercase English letters and is not part of a longer substring that is also satisfied the above condition. That means suppose we actually have this kind of, suppose this is one valid substring and we have one more valid substring, something kind of this. Okay, so they mention that this substring is not a valid substring because this actually you can see that this is common or overlapping with this substring also, with the second substring, all right, with a longer substring. So that's why this is not a valid. So we, what are they trying to say, that indirectly that we can generate a unique substring. That means suppose this is the total single S. Okay, okay, the single string S. Okay, now they mention that we can generate only a part of that. That means we, our substring whatever we can generate from the single string S, this cannot be overlapped, right? That means suppose we actually have one substring from here to here, that is suppose S1, and another we actually have S2. Next actually suppose we actually have this remaining substring string, that is S3. Okay, here actually you can see that there is no overlap between any of these two uh, substring, right? So that's, this is a valid combination, but we cannot divide something like this. This is not a valid, because here actually it is actually one different substring S1, here actually it is different substring as a S2, but here actually we have some common area, common words or common letters. So this cannot be a valid words, right? So we can take only ones. They're trying to say that now any character that is not a lowercase English letter or a valid hyphen act as a separator. That means any character except A to Z or hyphen, that will actually act as a separator. So return an integer array answer such that answer I is the number of occurrences of queries I as a word in S. So suppose first of all let's see the example one, that will be more clear actually. So this is actually our chunks and queries. Okay, we actually try to understand um, step by step. Okay, so first of all here you can see that we actually have two string in these chunks. So first of all I'll create a single string S that actually will merge this, right? So that will be hello world, then again hello, right? This is a single string S. First of all I will merge all of the strings that is present in this chunks vector, right? This is clear. Now actually what I'll do, I'll actually generate all the possible words that is possible from this string S. Okay, valid words. Okay, so first of all I'll start from left to right. This H, yes, this can be a new word. This can create a new word because what is the condition? First condition is that the letters should be lowercase English letters, that is between A to Z. So H is actually between A to Z. Okay, Next it is hello, E. So E is also part of A to Z, between A to Z. So this will be created with the word with the previous letter H, E. Next is L. So L is also same. Next is again L. Then it is O. Okay. Now this is actually a separate character, right? Because this is actually space, right? In between hello and world, there is space. Here actually we actually have space, right? So that means we will create only this a unique word. So hello is a new word that actually we can generate. Next, I'll come to this next character, that is W. Okay, this will again create a new word starting with W. Next is O, this is same. Then R, then L, then D. Actually, it is a space. Again, it is separated. So our word will be actually ending here. So this is a new word, that is world. Correct. Next, again I'll start continue from H. Okay, H, then E, then L, then L, again O. Now actually we have reached the end of the string. So this is again a new word that we have created. Now this is clear. These three words actually can generate from the string S. Now the first query actually it is hello. How many times actually hello we can generate from the string S? How many times? Actually first, this actually word is first time. This word hello, we have already seen this. So this will be frequency is 2. So for this our answer will be 2. Clear? Next is world. How many times I can generate world from the string S? That is only 1. So our answer will be 1. Next is WOR. So this word actually it is possible. Any of this actually valid word actually? No. So here actually you can see that you can actually ask me that or actually WOR is a part of this word. Why we cannot return 1? They mention that the third condition, WORLD. So this or WOR, this is actually part of this string, this substring. So they mention that any smaller substring that is overlapping with any other longer substring. So that's the smallest substring cannot be a valid word, correct? So that's why this will be our answer will be 0. So that's why we cannot generate any word that is WOR. So our answer will be 0. This is clear. Next, actually output is 210. I already explained why actually output will be 210. Next is this example 2. First of all, what actually I will do, I will first of all merge all of the string present in these chunks. That will be A dash dash B, then space A dash dash C. Okay. Now actually I have to generate that what is the possible valid actually what actually I can generate from this string S. First of all, I will start from A. Okay, this A actually valid letter between small a to small z. Next is space. Can I actually add this space into this word that actually we have already generated? No. Why? They mentioned that we can actually take only hyphen if only if it is actually surrounded by 2 correct letters, English letters, right? That means here also we should actually some letter, English letter. Here also we have some English letter, but here actually you can see that okay, in left side actually we have actually English letter, but in the right hand side we actually have again a hyphen, not any English letter, right? So that's why we cannot take this. So I'll actually break from here. This is a new word that actually I can generate, valid one. So hyphen is already gone. Next is this hyphen. Can I actually take this and I again start a new word starting with hyphen? No. Why? The same condition here actually. If I take any hyphen, the condition is that it should be surrounded by English letters. So in the previous, in the left hand side, there is no English letters. This is the first letter I am going to count this. So that's why it cannot create a new word. Okay. I'll go to the next letter, that is actually B. Okay, B is actually between A to Z, so it can actually create a new word. So I'll actually take this and go to the next. Next is a space. So this is a separator. So our word actually will be ending here. So this is a new valid word. Okay, next I'll go to the next letter, that is A. Okay, that this is between A to Z, so I can actually create a new word. Next is again hyphen. Can I take this? No. The same condition, because this is not surrounded by uh, any English letter characters. In the right hand side, we actually again have actually hyphen, so that's why we cannot take this, so I'll actually end here. So A is a valid word. Okay, next is again this hyphen. I cannot take this because this is not surrounded by two English letters. Next I go to this C. Okay, I can continue, but we have reached the end of this string S, so I'll actually end here. So here actually you can see that 4 words actually I can generate from this string S, correct? So what is the frequency for this word A? That is 2. And how many times actually I can generate B? That is actually 1. How many times I can generate C? That is also 1. If anything except these 3 words, if I get any string, our answer will be 0. Okay, so now go to this queries. So first what actually I actually have received, that is A. So A I can generate 2 times, so for this our answer will be 2. Next is B. B actually I can generate 1 time. Okay, next is C. I can generate 1 time. So this will be 2 1 1, correct? Now go to the code. This example output is 2 1 1. Clear? I hope this is clear. So I have already explained that how actually I will actually solve this. So I hope this is clear, but still actually I have explained the code actually. So first of all, I will actually generate the single string by merging all of the string present in this chunks vectors, right? So that's why string S is initially empty, and actually iterating all the actually string that is present in this chunks vector. So and merge this with a single vector within a single string S, correct? Now actually after this line number 9, I actually have a single string S by merging all of the actually these strings, correct? Hello world, hello. Okay, now actually what actually I have to do, I will actually check that whatever actually the valid what actually I can generate from this single string S, correct? And I can just store the frequency, because ultimately for this from this queries I have to return that how many times I can generate, or I actually have this any words actually. So that's why ultimately we need the actually frequency of that word. So that's why I'll actually take a map, not that map. So the key will be the string, the word valid word that actually you can generate, and the integer. Integer is the value will be the integer that is type of the how many what is the frequency of that word. Okay, now actually I will actually try to generate all the possible valid what actually I can generate. So what is the condition? So I'll start from left to right. I is equal to 0, and it can go up to n. N means the whatever the actually the string length size, means the S length of the string S. Okay, so now you check that I actually continue up to whatever actually I actually have valid index. Okay, so now actually check that what is the valid what actually I can generate. Okay, from this current index I. So first of all, I will check take a temporary variable string that is actually current word that is initialized with empty string. Okay, now actually continue up to where actually I can actually continue or actually valid letters. So that's why you can see that still actually if while actually I less than n, that means we actually have some valid index. So check that whatever the character or letter is present in this current index I, if it is between A to Z, that means we can take this current word or current letter into this current word. So that's why if it is between A to Z, I will take this current letter into this current word. That is we can generate from this current index I. Okay, now if suppose current letter actually whatever actually I have currently SI, it is equal to hyphen. If it is hyphen, what is the condition to take an hyphen? We can take condition is that it should be surrounded by English letters. So that means in the left hand side also we actually have some English letter, in the right hand side also it should actually have English letter. So that's why if current word actually it is not empty, that means we have already encountered a valid letter between A to Z, correct? If we already counted one valid letter between A to Z, then only it will not be empty. The current word, it will not be empty string. So left hand side we have already validated this. Now right hand side we have to validate this, that in the right hand side it should also have the any English letter character between A to Z. So that's why in right hand side also we will check that it should actually have some possible index, valid index in the right hand side, I plus 1, it should be less than n, and I'll check that whatever the actually character or letter present in this right index, right hand side of the current index, s of I plus 1, it should be between a to z. So that's why I'll check that it should be between a or between z, correct? Then only we will take this current hyphen. So if it is true, then only I will add this current hyphen si into this current word, okay? Else I will break from this. That means we cannot continue with this current valid word that actually can generate. I'll actually break from here because we cannot take this current hyphen. So that means we have already actually encountered a valid substring, whole substring, that is valid word. So I'll stop from here. I will break from here. So I'll break, else I will break from here. Else means this is a separate character. It can be anything except between a to z or hyphen. It can be space, it can be capital A, capital Z, any word, any letter can be possible. So if any other category letter actually we have encountered in this current index, that time actually I will break from here, okay? Else I'll continue, I'll go to the I plus plus. That means we have already encountered a valid letter or valid hyphens. Then actually go to the next. I'll continue. I will try to create a larger, actually the larger word. So that time I'll continue. I will go to the next index, I plus plus. Got it? So it may be possible that we have actually reached the end of the string s, or we have encountered a separator, or we have encountered hyphen, invalid hyphen. That time I will break from this while loop. Okay. Now I will check this in this current word. This is not a empty. That means we have actually some valid word. It is not empty, right? So that time I will increase the frequency of this current word. Whatever actually we have created, valid word actually we have created, I will increase the frequency by 1. Got it? And go to the next I plus plus. That means we have currently, or actually we have actually suppose encountered a one invalid hyphen that is not surrounded by English small English letters. Okay, that time currently I will be at this current hyphen, right? Now we have still actually have some letters in the right hand side. Still we can continue. So that time I will actually go to the I plus plus. That means we cannot create a new word with this hyphen. Suppose we actually have a dash dash b. Okay, so I actually currently I am in this hyphen. So this hyphen is not surrounded by English letters, so I will break from here. So I will be 1. Next, from where I can continue from I is equal to 2. So that's why before going to the next index or next word, I'll actually shift this I to I plus plus. The condition is clear why actually I'm going to the next I plus plus, because currently I'm actually invalid hyphens or invalid separate or word separator, or we have reached the end of the, it may be possible that we have reached the end of this. If it's still if I do the I plus plus, then it's still fine, right? It is already crossed the n. So anyway, next time it will break from here, this while loop, from this while loop, right? So this will actually handle that. Now after this line number 37, in this map, in this unordered map, we actually have that whatever is the valid word actually I can generate and what is the frequency of that word. Okay, so now actually we have to return this vector of integer answer. So answer is for each query is actually I have to return that. For this word, whatever the actually word actually I am trying to query. So for that word, whatever the actual frequency or how many times actually I have seen this word. So that's why I'll actually iterate all the queries. Okay, for each query I actually have the word they want to know, and I'll check from this map. Okay, either it will return 0 or whatever the frequency it is present there. So I'll store this into this answer vector. Okay, ultimately after actually checking all the queries, I'll return the answer vector here. Got it? I hope this is clear. This is pretty straightforward. You have to just follow the step by step what they are trying to say and just follow the code actually, nothing else. I have shared this code in the description, you can check that. And if you like the explanation, please like the video, and if you're not subscribed, please subscribe channel. Thank you, bye bye, see you in the next video.